This is programming in assembly, and in today's video, we are going to be looking at an assembly program in which we basically have to handle files and count the number of blank spaces, number of lines, occurrence of a particular character, as well as accepting the data from the text file. This is uh, this is our program 7.1. This is our program 7.2, and this is going to be our text file. Okay, so let's just say lol.txt, right? So what this file is going to do is this file will go to lol.txt and it will access everything that is written over here. Okay, then p72 p72.asm, this file will contain all the functionality such as counting number of spaces, a number of lines, etc., and occurrence of a character. Sorry, my spelling of occurrence is wrong, but whatever. I'll just start by section.data. Section.data over here. Yeah, and over here, we have to use not public but global. Global directives are to be used. Well, public is something which is not used in NASM on Ubuntu. What these two basically do is global and external. Global, as the word suggests, it's basically like making a variable global. Very analogous to the global keyword in Python. Extern, on the other hand, is similar to the Python import statement, where you can import another file, right? So using extern, you can import another variable from some other file which you are kind of using along with this current file. So now I've kind of put in all the variables required. So, this is the file name. This is the message. All the messages are pretty self-explanatory. I don't think there's any need to explain them further. Just now, what we have to do is some of these messages we kind of need to make them global as well, right? So actually, we make the messages global before we declare them. We'll go here and place, say, global. Then the message which I want to make global right now is we'll say OCC MSG, and we'll say DB, and we'll do num number of occurrences. Occur oh god, of occurrences, and we'll say OCC MSG len and equate it to the difference between current file offset and the reference of OCC message. Make new line and new line length. This is like our enter character which we'll use while formatting. Section.vss. VSS. Also, the difference between section.vss and section.data, I'll cover this again because the practical exams are approaching and this question is kind of asked that. So, section.data and section.vss are both stored in the data segment of the program. Section.data will be already kind of defined. So uska space and values will already be fixed, whereas section.bss will only have space allocated to it and no data as such. We need to define the counters for the various, I was saying, characters. So this is for space, this is for new line, NLCTR resb. We'll reserve 2 bytes, and CHRCTR will reserve resb 2 character length. So CHRCTR will contain like the frequency of the character we are searching. FD is going to be our file descriptor, which I'll put 17 bytes. Buffer actually, I'm taking 200 bytes. You can take as much as you want. If you think your file is like really large, then go for 500 or 1000 according to your convenience. Because what buffer is going to do in our case, it's going to contain all the contents of the file. That's how we're actually going to get the file ka length as well. I'll explain that in the further portions of the video. Also, the ch length that I said, that this is actually a variable for character count. So, like the entire length of the document, the entire length of the buffer is going to be stored in this character. And the length of that file, exact length, will be stored in ch length. Now we just need a bunch of counters. So CHARSB will do. We'll say 2, right? So now that we've defined our variables and all, we'll go ahead and we'll do global. We paste these over here. SPCTR, NLCTR, CHR, CTR. So we need space counter, next line counter, and character counter. And then we need those 3 counters. So CTR1, CTR2, 3. Yeah, that's pretty much it. And we'll need buffer as well. So buffer is going to contain all the file ke contents, na? So we'll like need to read the file every time we are searching for a particular character so that we can compare it one by one and like check if the character is a space or a new line character or something like that. Now we'll go for section.text. Section.text. Let's first of all do the formalities. Global underscore start underscore start. Oops, I actually forgot to write section.text.
Oh man.
But section.text is kind of read-only space. So you can't really define variables inside of it. Also, we'll need to import. So using extern, we'll import the function spaces, enters, and occurrences. Now, these don't exist in reality. We have to define those in p7 underscore 2.asm. But just for the time being, I'll write this. I actually forgot to do this, but we need a macro as well. So I'll just kind of copy paste it from our previous programs. So over here we have our macro RW and a macro exit as well. So we'll use this and we'll just paste it over here. You guys can also do the same thing if you've been following along the series. Um, this code is pretty much reusable only. I won't do a macro right now so that I can explain stuff better. In order for us to kind of access the file, open a file, we need to move 2 to RAX. So because since we just have to kind of read all the characters and all and no need to write anything in the file, we'll open it in read-only mode. Now we'll move RDI में the file name. So the file name over here is lol.txt. Should be written as file name, right? Now we'll move RSI में the value 2. Okay, so this is again kind of a keyword. Then we move RDX. RDX may we move 077. This is like the permission required for accessing a file, right? So now, if you remember, move RAX was our system read or write call, correct? So now that was 0 or 1 के लिए. Now 2 is read a file in read-only mode. Then RDI contains the file handler. So we are giving the file handler the name of the file, which is in file name. RSI contained the source index. We are giving it to read-only mode access. And 077 is again the permission required for accessing a file. Just a second, I'll write it down. Accessing a file in read-only mode. Also, commenting is something like it's a very good practice which you should like do in all of your codes. So today, like at the end of the video, I'll comment out this, like I'll comment the required sections of this code, and I'll show you guys like how I go about it so that even you can do it in your code wherever you're actually doing. All right. But the FD is basically our own variable. Okay, this is not something which uh, like the system provides. Okay. So see FD resb 17 we've done. So this is what that is for. So it will take all the contents of RAX. We've done bit tests in the last program itself. So I'm pretty sure you guys can relate to it. If you can't, click the info card. What we're doing here is, so FD and RAX contents are the same at this point in time, right? So it doesn't really matter what you compare. But if it is negative, negative equals error in file opening. Opening. Yeah. If the 63rd bit of RAX from the right, 0 is 1, that would mean that the contents of it are negative. So what we'll do is we'll do JNC, because if a bit is 1, the carry flag is set by the BT instruction. Okay, again, we've done this in detail in the previous video. So yeah, and we'll do JNC next, right? Then we'll do RW1 message. Well, not message 2, we'll do file error. See, this message we need to print file error. Okay, yeah. Then there's an extension in VS Code which allows me to like, autofill these. So it kind of makes my work a little easier. So I'll do that. File error len, yeah. If you're coding in VS Code, then prefer this as well. It's like kind of a life hack, right? So this is basically the error message. Error message, right? So this is our error message which we are going to print. So basically क्या हो रहा है इधर अगर carry print नहीं हो रहा है, so if the carry is not set by BT flag, it will go to next. If it is set, nothing will happen over here, right? So it will go here, where it will be like, okay, RW file error print hoga, and then we need to exit, right? Because there is a faulty file which has been detected. So it makes sense to exit. So what I'll do is I'll do JMP and I'll do exit. So as far as I know, you can give macro calls in jump statements as well. It works. Over here, we need to define the label next, right? And then यहाँ पे we need to do RW1 and file open, right? And file open length, so that this message will display key file opened successfully. Yeah, it's an affirmation, guys. It's an affirmation. Every time the program wakes up in the morning, it says this itself. Filed opened successfully, filed open successfully, gigafile, 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 yeah. Okay, now we've printed the success message now. Now what we have to do is we'll do RW0 and we'll put FD contents into buffer, and I'll put 200 here since that's the length of the buffer, right? We did buffer SB 200, so that those are डालना पड़ेगा. If you have कुछ अलग length for buffer, put that corresponding variable over here. Okay. What we are basically doing over here is reading contents of the file. तो अभी फाइल से सब कुछ रीड किया एंड वो बफर में स्टोर हो गया. That's why we did this. RX contents into FD, right? So it was so that we can read it. If you don't want to do it, an alternative would be push RX to stack and then pop it as and when you require. You can do that as well. So जो length है buffer का, we need to store that as well. So what we'll have to do is keyword of a variable called buff length which we used and RAX. So we did the second program of this NASM series, which we did is exactly this concept cut demonstration that RX basically stores the length of every string which kind of is processed. In that program ka case, it was the string which the user entered. Here it's the string which is the file, right? Initializing the values of CT, the counters, with the length of the buffer. What that is going to provide is it's going to provide like a length जिसको हम decrement करते जाएंगे so that our kind of spaces, enters and occurrences will be able to run for the entire length of the file. Okay, so we'll say initialize uh, CTR var with file length. Actually, I should say buffer length. This is more appropriate, right? The main stuff of this program is done. Okay. Now there's just kind of the messages which you have to see. So now we printed the message for spaces. Now we'll call the spaces method. What that does is counts number of spaces in buffer or file. Here we are using file and buffer synonymously, but in your Viva always know that buffer is the correct term. The reason for that is we are kind of accessing file के contents एक ही बार using file descriptor. What we are doing is एक ही बार we are kind of transferring all the contents of the file to buffer, and then all the operations we are performing on that buffer itself. So we are not actually touching file in any way. We're just reading the contents. So buffer is an appropriate term. Also, guys, you can probably observe it over here as well. We've given 4 arguments to the macro, but the macro actually takes 3 arguments, right? So the reason for that is over here we'll have to tweak the macro a little bit, right? So we'll need to give 2 here, 3 here, and 4 here so that we can like fit in this, this line in the macro. Or else if you want, you can directly do move RAX 0 and contents of FD and all. But क्यों ना इतना झंझट? So See I'll do the same over here as well. I'll do 2 file name, uh, 2 again, and 0777 shortcut. Also, your code now looks cleaner, right? You just omitted 4 lines from your code. So that's a good practice, I'd say. Input from the user, right? To like कौन सा character search करना है, इसका input user से लेना पड़ेगा. That we have to write the following logic, and then we call occurrences, and then we exit. Okay, that is pretty much it, guys, for program 7.1. So it's pretty small only. Just remember these keywords over here. These are pretty important. Extern over here, global over here, ऊपर भी. Second part of it, where we actually have to write all the functions and whatnot, right? So for the functions, first of all, here in the section.data, there's no as such stuff that we have to define. Okay, all of what we had made global over here is what we'll be importing using extern, and the same thing in section.data bss, sorry, so bss. Okay, um, so over here also we just do extern, and whatever we made global in the section.bss of this file over here, we put it in the extern here. So we can define the macro again over here. I just copied it from the previous file, and that's pretty much it for section.bss. There's just a few easy little procedures over here, so we'll start with those. So we do start with section.text. Also over here, just keep in mind that you cannot use global underscore start. Okay, you have to use some other name. So we'll say global functions, and we'll say functions. Done. Yeah. Don't put start or underscore start over here. Okay. I'm putting functions over here. If you want, you can put something like main1, main2. I don't know if main is a keyword or not, so I would suggest that you don't use that. Then again, it's all right. Even if you do, you'll like get to know, right? Yeah. And then see, so over here we had made these extern. Now we'll paste it and make these global either so that we can access them. So now the basic logic behind spaces, enters, occurrences, and all of these is basically that there's going to be this file. Okay, so this is our file. The file, lol.txt or whatever, and we have some content written over here, right? So what we are going to do is, like in this program we're basically reading everything, putting its length in a variable, and storing and the entire contents in a variable as well, right? So now over here, say for example, there's a space at the end over here. So what we are going to do is we're going to go one by one in this entire document and compare each and every element with the character for space. If we find one, then we'll increment the counter. If we don't, we'll just keep on going forward. Same thing for enter, same thing for occurrence of a particular character. Say J, we'll compare each and every character, and if it is J, we'll increment the counter. If it's not J, we'll just keep on moving forward. That's the basic logic we're going to implement. Okay, so it's going to be the same for all three procedures. So for spaces, I'll just write the program and Like I'll try to explain it. We moved buffer to RSI. Okay. So इससे क्या हो गया कि all the file के contents now basically RSI is pointing to the start of the file, right? Because it has the initial reference. So now after getting the initial reference, what we're doing is we're moving RSI का एक character, so एक single byte of RSI to AL and उसको compare कर रहे हैं 20H से. 20H is the character for space, right? Now if the character contained inside AL is equal to a space or 20H, then what we'll do is we'll say JE jump if equals, we'll do space increase. So that's like a label where we'll like increase the space counter. Okay, now we'll do this stuff will be executed in case of the this will be executed when the character is not space. Okay, so yeah, now and then we'll do JNZ up and JMP next 4. Okay, SPCTR is the counter which has spaces in it, right? So increment that and we'll decrement byte of CTR1 1. That's pretty much it, guys. And then we'll do J and Z up. So as long as that is not 0, it will go back to up. Now, the reason why we are doing another additional CTR1 instead of just, letting RSI run through the whole course of the buffer is because, like, how will you stop RSI from incrementing on forever? There's no as such like way to stop it. If you stop it before the file ends till the exact length of the file, it will work. If you go beyond the file limit, it will give you a segmentation fault or an exception. And like we don't want to handle that right now, right? So that's why we have an additional counter. That's why the need for an additional counter CTR1 arises.
ठीक है.
Here, next 4 may actually we'll name it as display, disp res space. Disp space will do disp space. So it displays our spaces. So in disp space, in a disp space, what do we do, guys? We basically go to SPCTR over here and we add 30H to it. Now, why are we adding 30H to it? So that we can convert the hex character to ASCII hex, right? And the reason why we are not using a display loop and procedure over here is because this is a single kind of, yeah, well, the single digit. Need an entire display function for a single digit. You can just add 30H. Also, this kind of puts a limitation on the program on itself. That means that if there are more than 9 spaces in your program, this will not work. This will give you like an incorrect answer for it because even if you convert this hex into ASCII hex, you will still have to convert that into BCD so that you can do it into display it as 11, 12, 13, 14 instead of A, B, C, D, E, F, G. And again, even if you convert it into ASCII hex, right? F के बाद it will keep on going to G, H, I, J, K, L, M, N. So there's actually not really a lot of sense, I'd say, in converting this into ASCII hex using a display procedure. So the best bet over here is to add 30H and make it work for single. Actually, I'll write it over here only. Convert from hex to ASCII hex. Yeah. Then we'll do RW 1 comma 1 comma SPCTR comma 2. We'll do RW 1 comma 1 and we'll do NL and NLN. Uh, and then we'll have to do ret, right, for return. So NL we've imported, yeah, is an extern, and this is it. For enters as well, it's literally the same thing. So I'm just going to copy this and okay, so over here I just copied this thing and I just kind of edited the names a little bit. So ENT up, enters, increase, and disp enters, as well as I changed the counters over here. This is supposed to be NLCTR. Is that instead of 20H, 20H was, and 20H was the character for spaces, right? 20H was the character for spaces. Now for enter, we have 0A. So 0AH, and obviously because it's in hex, we have to write it followed by an H. So 0A is the character for enter. All right. We can write it as 0xa as well. Then there's no need for putting an H behind it. But yeah, you can write it both ways, guys. So you can write it like this also, or you can write it as 0xa also. It doesn't really make any difference as such. But if you're writing it as in this form, make sure that it's a capital A. Next procedure is occurrences. Occurrences is pretty much the same, but there are a few changes because we are accepting something from the user itself, right, for searching. So the procedure for occurrences looks something like this. Over here, I'm comparing the contents of BL with AL. So if they are equal, we'll increment, same thing. And if they are not equal, we'll just keep on continuing. Also over here, there's an additional message which basically shows like it's this message over here. The OCC message which we wrote, number of occurrences. So that's what we are printing over here. And that's pretty much it, guys. Uh, yeah, that's the entire program. Also, I went ahead and made a separate folder for this. Also, yeah, I made a separate folder for this, but don't worry, you don't actually need to make any separate folder to be able to run the program. Let's just make another text file over here. We'll call it lol.txt, and I'll say over here like, share, and subscribe. Yeah, we'll put share and subscribe on one line so that there's a space in between, and we'll say to my channel. This is the guys, just so you know, these are like the golden words for every guy making content on YouTube. Yeah, I have to put this in my video at least once, or else my channel will get banned. Jokes apart, our file, we've made a file, right? lol.txt. Now we'll run this. So to run this, now there's an easy way and a difficult way. So I'll show you kind of a cheat code which you can use while testing or debugging. What you can do is NASM ELF64, and this is like the normal command, right? We'll do p7 underscore 1 dot asm. Now along with this you can do and do NASM f ELF64 p7 underscore 2 dot asm. So now, okay, hold up. It says, oh, I'm in the wrong directory. Uh, yeah. Now we'll do this again. So yeah, this got compiled. I was actually on the ASM practice directory. I was the directory outside this one. That's why it said no directory. But anyways, it got compiled. Now what we'll do is we'll like convert the object files into an exe using ld dash o, and we'll do p7, which will be the name of the exe, along with p7 underscore 1 dot o and p7 underscore 2 dot o. These are the object files, and that's the uh, exe, and we'll do dot slash p7. Right, so we got number of spaces in file 5, number of lines in file 1, and let's say we'll search capital S. That I think there's only one capital S where we wrote subscribe. So okay, no. So yeah, share and subscribe. There are two capital S's which exist. Also, the cheat code I was talking about. So that is basically just like we've done and for these two commands. You can go ahead and do and for ld slash o p7 and p7 underscore 1 dot o as well as p7 underscore 2 dot o. And now after doing this, you can, if you want, you can also do dot slash p7, which is just outrageous according to me, but you can do it if you want to. And yeah, just a single line and your program runs. And then we'll search, say small s we'll search, so we'll get 1 because there's a small s in subscribe as well over here. So yeah, that's pretty much it, guys. This is like the entire program. Now I've commented out, like I've commented and described a lot of the sections while explaining the code itself. But for the second section of the program, we'll do it right now. All right, so over here for converting hex to ASCII hex, I'll just copy. Acha, it's already copied. Yeah. Now, yeah, these over here are imported from p7 underscore 1 dot asm. So that's that. This is the rewrite. I'm not going to comment and describe this because that's like way too basic. Now this over here, we can comment, say, we'll say contains starting reference slash location of, actually no, contains content of entire file. So it contains the contents of entire file. And over here we'll say comparing each character with uh, space or 20h, or yeah, that is increment space counter to update count of spaces. And the same is to be done over here as well, pairing each char with contents of BL, right? Or char entered entered by user. Done. And with that, we've like commented our code as well. Thanks for watching. If you liked the video, hit the like button. If you didn't like it, hit the dislike button. Study for your exams.